Section 2 of Chapter 5, Evaluate and Graph Polynomial Functions. So here again, it's going to be the same type of thing you've done already, but we're going to up the ante just a little bit. Instead of just binomials and trinomials, we're going to change them to polynomials. All right, so backing up and making sure we have all the terms and we're talking about the same things. A monomial, you'll remember, is simply a variable, a number, a variable, or a product of the two. So an x, or a 4x, or a 3. All of those are monomials. A polynomial is a sum of monomials. So this would be like 3x plus 2. That's a polynomial. But we can have lots and lots of them or just a few. If there's more than one, now it's a polynomial. All right? A polynomial function has to have exponents that are whole numbers. So this is the important part. This is the new stuff. Write it down. The exponents are whole numbers. The coefficients are real numbers. So if you have something that's claiming to be a function and the exponents are not whole numbers, if there's a decimal or a fraction or a variable involved in the exponents, then this is not a polynomial function. And if the coefficients are not real numbers, then this is not a polynomial function. So real numbers, remember, are anything that can be put into a fraction form. So if there's any imaginary numbers, now you don't have a polynomial function. All right, so once you have those functions, now you can put them in standard form. In standard form, it's just when the terms are in descending order of their exponents. So if you've got a squared term and a fourth term, the fourth term has to come first because that's bigger. So x to the fourth plus 2x to the third minus 3x squared plus 4x plus 0 or something like that. So as long as the exponents are starting from the big and going to the small, all right? The degree of that function is the largest exponent. So if the largest exponent is a 5, then this is in a fifth degree polynomial function. So the degree is the largest exponent. The leading coefficient is going to be the coefficient of the term with the largest exponent. And the reason we call it the leading coefficient is because it's going to lead if it's in standard form. If your function is in standard form, the first coefficient, the first number in front of a variable, is going to be the leading coefficient. So it has to be the number in front of the term with the largest exponent. And the constant term is still the constant term. It's the term that has no variable. And if it's in standard form, this is going to be the last term involved. All right. So if you will look on page 337 with me, please. Page 337 has a chart that talks about if in standard form, it's got in the very middle there with the common polynomial functions, a constant term has degree of 0. If it has a degree of 1, so if it's got an x but no x squares or cubes, then it's linear. All right. If it's got an x squared, it's quadratic, and we've worked up through those. If it's got an x cubed, it's cubic, and if it's got an x to the fourth, it's quartic. All right. So those are terms that you will need to know. And I believe we've used linear and quadratic already. So the cubic and quartic are the new ones here. So what we're going to do with all of that information, once you get it all in your notes, you can look at it in your notes while we do some examples with it. What you're going to need to do first is you want to identify, I would like for you to identify polynomial functions. So I want you to first tell me, are these polynomial functions? And then once you know that they are, I want you to put it in standard form. I want you to tell me the degree, the type, and the leading coefficient of those polynomial functions. So you have to go back to your definition of a polynomial function and determine, number one, is it? So the first one I have is the function of x equals 6x to the 1/2 power plus 5x. And you can immediately say, and actually if you want to pause it and do all of this, you should be able to do it quickly and easily. So let's walk through them after you've done them. All right, the 1/2 power is not a whole number. And remember, the exponents have to be whole numbers. So this means this one is not a polynomial function. Because of that 1/2 power, it's not a polynomial function. You're done with that one. All right. G of x equals negative 8x to the 5th minus 4x squared plus the square root of 10 plus x to the 4th. So the two things that have to be true, the exponents have to all be whole numbers. I've got a 5, a 2, and a 4. Those are all whole numbers. We're good. The coefficients are real numbers. So the coefficients are the numbers in front of the variables and our constants, and those are all real numbers. So this is, in fact, a polynomial function, so it's yes. Now, once it is a yes, I have to put it in standard form. Remember, standard form is putting the exponents from largest to smallest. So I've got negative 8x to the 5th. The 4th is smaller, so keep the whole term together, plus x to the 4th. And if you want to mark them off as you go so that you remember to get them all, that's fine too. The squared term is next, minus 4x squared. And the last term left is your constant, the square root of 10. So that's standard form. The degree is simply, oh, this is in the 5th degree. So degree of 5. You can say 5th degree or you can just say 5. The type, because this is a 5th and it's larger than 4, this one is not going to have a name. It's just a polynomial function. And the leading, let's see, what do we have? So the type is just it's a 5. It's not a quartic or a cubic and the leading coefficient is negative 8. Because it's the number in front of the largest term. All right, the next one, 4/5 x squared minus 1 plus x to the 3rd. Is it a polynomial function? So are my exponents all whole numbers? A 2 and a 3? Yep, we're good to go there. Are the coefficients all real numbers? I got a 4/5 here, but that is a real number. So even though we don't like fractions, I like them, but maybe you don't. All right, it is still a polynomial function. So this is a yes. So we have to go through the steps. Is it in standard form? No, this one is bigger. So x cubed plus 4/5 x squared minus 1. Now it's in standard form because the largest to the smallest. The degree is 3. The type, if you'll go back to your chart on, did I say 337? Yes, 337. Because it's a 3, it's cubic. So that's the type. And leading coefficient, remember, if there's not a number in front of the variable, there is a number, and that number is 1. So your leading coefficient is 1. All right. H of x equals negative 3x to the 4th minus 9x to the negative 2 power minus 4 plus x to the 4th power. So first, now my brain immediately says, oh, we can put those 4th powers together, and that's true, but right now that's not what we're doing. Let's first decide, is this a polynomial function? Are my exponents all whole numbers? And if you'll remember, whole numbers are your counting numbers, and negative 2 is not a whole number. So this is not a polynomial function. So you're actually finished with that one, and I don't get to put my 4th powers together. Darn. Okay, so the next thing we want to do is, so now we know what they look like. The book has a section in here that's really kind of cool, and it's kind of a why did you put that here? But that's okay. We can do it that way if that's what the book wants, right? So because what they have is they have us figuring using direct substitution to solve or to evaluate polynomials, which is fine. We've done this before. Let me show you, and they give us a shortcut, and it was pretty cool. Here we go. So f of 2 means I'm going to put 2 in for all of the x's. So I want f of 2 of this equation, or of this function. So you know how to do this already. what this says is with this expression, I want to put 2 in and fill in all of the x's for that. So you know how to do that. -3, 2 cubed plus 2 squared minus 12 times 2 minus 5. Right? And so when you do that, 2 to the 3rd power is 8. 8 times -3 is -24. Plus 2 squared is 4. Minus 12 times 2 is 24. Minus 5. Look at me doing all this mental math. I'm making sure I've got it right because you know sometimes I don't. All right. And when we combine all of those, we get -49. And I did do it already, so you check it and make sure I got it right. Now, I'm not going to spend a lot of time on that because you know how to do that already, but I'm going to show you synthetic substitution. This is so cool. Synthetic substitution, what we're going to do is we're going to take this exact same equation and we're going to figure it out using a shortcut. What you're going to do with synthetic substitution is you're going to take the coefficients of each term, just the coefficients. So you're going to take the -3, you're going to take a 1, you're going to take a -12, and you're going to take a -5. Now, one thing to tell you, because I didn't use an example that did this, if you're missing one of these terms, if you didn't have an x² term, you would need to put in a 0 where that x² term would go in order for this process to work. All right? Okay, so then it's almost like we're doing a kind of an upside down division problem is what this looks like, but that's not really what's happening. So here's what you do. This is really cool. So first, just bring down this -3. And then you multiply the number that you're putting in, your value for x, you multiply that times what you have at the bottom. So -2 times 3 is -6, and you put it here. And then you add these two terms and bring it down. So 1 and -6 is -5. And then you just keep doing that to the end. So 2 times -5 is -10. So bring that up here and then add down and get a -22. Multiply 2 times -22 is -24. And -5 plus -24 is a -20. 40. Oh man, I hate it when I do that. Okay, here we go. Because 22 times 2 is not 24, it's 44. I'm glad I caught that. All right, here we go. So now -5 plus a -44 is a -49, which matches what we got the long way. Wah! Check that out, pretty cool. All right, there are some guided practice ones to do if you'd like to practice that again, or you can go back to any of the equations that we've already solved before and work them that way also. All right, here we go. The next thing, all right, the last thing we're going to talk about is actually graphing, because we said we were going to evaluate and graph polynomial functions. So the graph of a polynomial function is going to be, we worked with linear, they were straight lines. With quadratics, they were parabolas. So now, because with a polynomial we can have any number of degrees, we're going to have kind of, just a generality to fall back on, because there's really not a trick. We're going to have to just plot points until we figure out what on earth this shape looks like. But there are some general shapes that we can count on. And so what we're going to start with is the reason we were finding, well, what degree and what is the leading coefficient, this is why. If the degree of your polynomial function is odd and the leading coefficient is positive, then you're going to end up with a graph that has that starts at the bottom of your graph and goes toward the top. And so it's going to, the left end is going to go down and the right end is going to go up. Now the number of turns is going to vary depending on your function. But you can know that the ends are going to be such that if it's odd, then you're going to have one up and one down. If the degree is odd, you're going to have one end up and one end down. If the degree is even, you're going to have both ends up or both ends down. All right, so if it's odd, one up, one down. If it's even, both up or both down. If your leading coefficient is positive, then you're going to end up going up. So if you're odd, you're going to start down and end up up. And if you're even, you're going to start up and go up. All right, if your leading coefficient is negative, then to the right, you're going to end up going down. All right, so then that means that if your leading coefficient is negative and your degree is odd, then you started at the top and you went down. But if you're even, you're going to start at the bottom and go back to the even. So, odd is one up and one down. Even is both up or both down. Positive, you end up, the end of your graph to the right of the graph is going to go up. And if it's negative, the end of your graph is going to go down. All right, so all of that said, there's going to be some examples where they say, here's a graph, explain to me the degree and the leading coefficient of your graph. So we can look at this graph and we can say, well, we know that one is up and one is down, so we know the degree is odd. So we've got odd degree, and if we're ending going up, we know that the leading coefficient is positive. So this is an odd degree polynomial function where the leading coefficient is positive. All right, so the reason that does you any good is because when you graph polynomial functions, you're just going to have to graph points and graph points and graph points and then check those endpoints to see if they fit what they're supposed to fit. So that way you know, ooh, yep, I did get to the end because it's going on and on and on forever in this one direction. So let me find I've got the points, now I've got to find the equations that I was working with, or the functions. We're going to start off. If you feel brave, then go ahead and shut off the video and graph them and see if you can get it. Otherwise, watch and see. Here we go. We're going to do 2. What's the other one? Okay, here's our 2 functions we're going to graph. All right. So what we need to do first, when we're graphing polynomial functions, you may want to put these 2 steps into your notes. Step 1, graph a bunch of points. Step 2, check your ends. That's it. All right. So with the first one, just in the interest of time, I put in the points. So here we go. So for this equation, or for this function, if you put in a -3, you're going to get out a 24, -2, 3, and so forth. So what we're going to do is we're going to take our graph and we're going to graph these points. So -3, 24. Now -3, 24 doesn't fit on my graph, so I'm just going to it starts up here somewhere crazy. We know it starts way high. So this one is -2, 3, -2, 1, 2, 3. That's on my graph. -1, -4. So we know we go down here somewhere. 0, -3. 1, 0 is here. 2, -1 is here. 1, 2, 3, -12 is somewhere off the chart here. So we can see that we went somewhere from way high and we came way down here. Oh, and it did something like that. So once you graph your points, then just play dot to dot and put them together and then look to see, did I do it correctly? The way you'll know is this. Your degree in this case is negative, or is odd. So the degree is odd, so I should have one end going up and one end going down. I do. I have one up and one down, so we're good there. And my leading coefficient is negative, which means that the right-hand side of my graph should go down forever. And that's what it's going to do. So this is correct. All right, so let's do the other one. You go ahead and try some points real quick and then come back to me. Did you try them? Here we go. So there's our points that we figured by doing all these crazy 4th powers and 3rd powers with our calculator. And so we end up with, wow, Negative 376 is in the stratosphere here somewhere. 1, 2, 3, somewhere way high. Negative 212 is still pretty high. Negative 2, mine goes up to 10, so 12 is going to be about here. Negative 1, 2 is right about here. 0, 4 is, oh yes, 4 is here. 1, 0 is here. 2, negative 4 is here. And 3, whoa, 322 is way up here somewhere. So now dot to dot, somewhere way up high goes that way, and then down, oh, it goes up, and then down, and then up. Okay, so crazy looking graph. Let's see if it fits. Let's see if the ends fit what we should have. So we've got an even degree this time because 4 is even, and so we need to have either both up or both down, and both ends go up, so we're good to go. And our leading coefficient is a positive 1, so it's positive, so the right-hand side should be going up at the end, and it is indeed going up. So our graph should be correct, and so we're done. So really and truly, the hardest part of that is just coming up with all of those points by using all of those, use your calculator for all of those squared and fourth terms and fifth terms and big numbers. And so it's okay to just kind of put an arrow way up if the point is way off your graph. That's okay, just kind of like I did. All right, here we go. Good luck. I'll see you soon.